Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Are you bored with writing scripts to move data into SaaS tools like Salesforce, Marketo, or Facebook ads? HighTouch is the easiest way to sync data into the platforms that your business teams rely on. The data you're looking for is already in your data warehouse and BI tools. Connect your warehouse to HighTouch, paste a SQL query, and use their visual mapper to specify how data should appear in your SaaS systems. No more scripts, just SQL. Supercharge your business teams with customer data using HighTouch for reverse ETL today. Get started for free at dataengineeringpodcast.com/HighTouch. Your host is Tobias Macey, and today I'm welcoming back Nick Schrock to talk about the evolution of Dagster and its path forward. So, Nick, can you start by introducing yourself?
Yeah, thanks, Tobias. My name is Nick Schrock. I'm the CEO and founder of Elementl, which is the company behind Dagster, and it's an honor to be here.
And do you remember how you first got involved in the data ecosystem for folks who haven't listened to your previous episode?
So I worked at Facebook from 2009, 2017, and I didn't really work in data management then. The thing I'm known for from that period of time was I was one of the co-creators of GraphQL, which has gone on to be broadly adopted open source technology. And when I left Facebook, I was figuring out what to do next. And I started talking to companies both inside and outside the Valley about what their biggest technical and engineering liabilities were. And the notion of data infrastructure and ML infrastructure just kept on coming up universally, both in terms of just raw developer and engineering pain, as well as the impact on the outcomes of the organization. And I dug into it, and pretty quickly I discovered, I like to describe it as the biggest mismatch or gap between the criticality and complexity of a problem domain and the tools to support that domain that I'd ever encountered. It was also a critical domain insofar as, the job of data management is to curate data assets, which are the basis of all decision making in the enterprise these days, whether it be a human making strategic decisions or a machine learning model making automated decisions. So it's a really important problem. There are practitioners in pain, which is very motivating to me. And I started digging in, about 4 years ago now.
So that's a bit of the story behind sort of what motivated you to build Dagster. I'm wondering if you can talk through some of the core concepts and design elements that you baked into some of those early versions of it that you were aiming at starting to target some of those pain points that people were experiencing in the conversations that you had.
So very quickly, orchestration stuck out as both a pain point and a massive opportunity, because most of the orchestration solutions that people had used, they were fairly narrowly conceived as purely operational tools, meaning like this is how you order and schedule things in production. And I thought that was a very missed opportunity. What I found was these orchestration systems were in their developer lifecycle. The whole job here is to build graphs of computations that consume and produce data assets. And, solutions like Airflow and the container-based solutions really didn't have smooth local development experiences. And then I also found that the DAGs or graphs they encoded were very metadata poor, and they were not data aware typically. And I thought that was a huge missed opportunity, because the DAG can be a source of truth for a large number of things. You can encode what data is produced, that data's lineage. You can make it much more self-describing, the computations themselves. You can structure this thing so that the computations can be rendered in tooling prior to computation, which is actually very important for making it a system of record for your data platform. And so that was kind of the entry point and why I started Dagster.
Given that sort of foundational concept and the idea of building much richer metadata into the computation graph that you're building up with Dagster, and we've talked a lot about some of the core elements and the architecture of the project in the previous episode, so we'll add a link in the show notes for people who want to revisit that. But that was 2 years ago now that you were on the podcast last, and I'm sure a lot has changed in the tool and in the ecosystem. So I'm wondering if you can just talk through some of the ways that the project has changed, how the community has evolved, and some of the ways that the ecosystem around the project has shifted your goals and priorities.
So it's a much more mature and robust system now, and it's been slightly, conceived a little differently insofar as the original vision was to have Dagster be more of a pure software layer over other orchestration systems. And it became clear relatively quickly, actually after that podcast, by the way, I can't believe it was 2 years ago, it became relatively quickly that we needed more vertical integration to achieve our objectives and satisfy our users, meaning that effectively we built like a full orchestrator underneath the hood because we got feedback that people were like, we love the programming model, but we want to only adopt one thing, not two things. And that made sense. So in terms of high level technical properties, that is the biggest shift. And it really changed the scope of the project, and observing us very well. The community has changed and grown dramatically since then. We had like no usage and maybe like 150 people in our Slack when you were kind enough to allow us on air. Fast forward, now we have thousands of people in our Slack and really awesome design partners that power their data platforms and ML platforms. Good Eggs, Prezi, Loom, GoPuff, UNICEF, which is a nice one, Drizzly, Scale, Mapbox, whole bunch of awesome users. The Philippines government used us for the data platform for their COVID response, which was surreal. It's been deployed into fintech and telecom companies in Southeast Asia. So, we made a ton of progress on that front. We've grown the team a bunch. We have, 20 people on the team now and, making a ton of progress. And then, I think we're going to talk about later, but we're also, on the cusp of doing an open announcement of our cloud products. So there's been massive progress on a number of fronts in the last 2 years.
As you have been exploring the data ecosystem, particularly given your sort of fresh eyes on the problem, I'm wondering what you have grown to see as some of the sort of core foundational challenges and complexities that exist in the ecosystem, and some of the things that have been sort of transient or short-lived or potentially mutable in the problem space as sort of people try to deal with the complexities that arise due to the nature of data.
So a lot of foundational things have not changed. There are fundamental underlying properties of data processing applications. I use that term generically for ML training pipelines or ETL jobs or data pipelines because they're fundamentally doing the same exact activity. They're fundamental properties of those computations which have not changed, meaning that they are across organization but interconnected. So there's multiple tools in play. That has not changed. It's multi-persona and they span teams. That has not changed. And then these systems also have this unique property in that the people crafting their computations do not have control over their inputs. And this is very distinct from web applications where the programmer actually has much more control over the user. So you put a form in front of them. If they mistype something or misformat something, you throw up a red box and say, please change this. So you can constrain your inputs and therefore you have much more control. That is not true in data processing applications where you just get data from an external source and it is what it is. You can't control it. Often you can't have the upstream person change it. So you just have to be far more defensive in your computations. And it's much more akin to a manufacturing process where, instead of an assembly line, you have an assembly DAG and the raw materials flow through the system. In the end, you want a meaningful output. As in manufacturing, you want QA at every step. And then, that property makes it so that you have a much more intricate relationship between your data assets and the code that produces your data assets than you do in other forms of programming. So you can think about a particular data asset might represent the data that was produced on a certain date. it was processed by code that was last updated on a certain date and then recomputed at a later date. So there's like 3 notions of time just in that sentence. And that is really hard to deal with. The complexity is almost like hidden and subtle because a lot of times you look at the code actually and just like, there's like 2 lines of pandas code and you're splitting a number. Why is this hard? And it's hard because of those underlying properties that I referred to. And that is not going away. I think what is, transient or incidental complexity that's going away is that it's becoming received and accepted wisdom that the way out of a lot of these problems is to apply software engineering techniques to the data domain. And I think you're really seeing that. Like a good example of this is the meteoric rise of DBT, right? Which is really like taking the lessons of software engineering and then getting analysts to adopt that. They retitle themselves analytics engineer and they're dramatically more productive and leveraged. And I think that lesson needs to be reapplied across multiple domains in data, and I think I'm thrilled by that development.
There are a number of different directions to go from here. And I think that the first one I want to talk about is this idea of applying software engineering principles to the domain of the data engineer and some of the challenges that brings in because of the fact that data, unlike software engineering, is inherently cross-functional, where it requires participation from every member of the organization because of the fact that there are producers of the data, consumers of the data, manipulators of the data, and they all need to be able to align and interact along the entire process. And so there are concepts such as no-code or low-code platforms, or the the sometimes loved, sometimes hated UI-oriented pipeline building tools, and then this movement towards, X as code, where code essentially means a YAML file or a JSON definition, or the other trend that's pulling people in another direction of containerizing everything so that you can have multiple languages coexisting in the different stages of computation. And given the fact that Dagster is unapologetically a software tool and written and implemented and consumed in Python, I'm wondering what you see as some of the sort of potential challenges and opportunities and just the overall sort of acceptance of this very unapologetically software-oriented approach to managing data computation and some of the opportunities for being able to bring in some of these other concepts of, polyglot data applications or data applications as a more sort of low-code, no-code approach.
There's a lot to unpack there, but I guess we could start with the premise that, we like to say that Dagster is built by engineers for engineers. Our core adopters always self-identify as engineers, and that's very deliberate. So, frequently the people who really latch on to Dagster and really get a ton of value on it describe themselves as data platform engineers, which means they themselves are engineers, but they are serving tons of non-engineering stakeholders. So I just brought up DBT, right? We have platform engineers who work lockstep with analytics engineering teams. Those analytics engineering teams are still coding in DBT, but we have a nice integration, and then those DBT users can use us to understand how their computations interrelate to all of their stakeholders, and then also have kind of data observability so they know how their assets interrelate. And, even though I'm a grumpy engineer, I think there is a place for low-code and no-code environments properly conceived and placed within a software engineering process. So, I actually have kind of a picture in my head, which we don't have to get into, and I even have a domain for it, but I'm not going to tell you what that is because I've had domain names stolen from me before. For a no-code, low-code tool that plays nicely in a composable way with the rest of the data platform, instead of having a completely siloed system that is completely foreign to our engineering process. So I think there's a spot for that. But really what I see happening almost, there's a term du jour out there, the modern data stack, right? There's debate about what it means, and is it a set of technologies or an emotional state? And, I really think it's a mindset, a way of approaching the problem. And effectively, data infrastructure is being rebuilt from the ground up for the modern cloud era and the software engineerification of data. So starting at the most primitive levels where there's an ingest tool, a cloud data warehouse, a transform layer, and a BI tool. But there's going to be more and more tools kind of embraced, under that mantra, both because in reality, people want to do more things. And then there's also the incentive structure where every vendor is going to label themselves the modern data stack X. And you're already seeing that, right? But I think they're actually, for low code, no code stuff, I think there's definitely going to be a space that can deliver a ton of value for low code, no code solutions that align with the values of the emerging modern data stack that can bring in a business user, but in a way that comports with the software engineering process laid out by the data platform team.
And then along the lines of the sort of, data pipeline as code, where I just say, here's my YAML file, I want it to do the thing, and I just throw that at Dagster, and Dagster does what it's supposed to do. I'm wondering if you see a potential future for that, where maybe you have a set of kind of pre-built, off-the-shelf operations that somebody can just reference in a YAML file to say, I want this thing to happen, and I want it to tie into this other thing, and I don't want to have to actually write all of the code that does those different pieces because Dagster comes with all of those out of the box for me.
Totally. So I think there's two components to what you're talking about. One is like a YAML file or an equivalent DSL. We have users who do that now. Like, we didn't want to prescribe a single YAML spec to rule them all because we find that the needs are often context specific. But what we do tell people is like, I wrote it, I think, actually. We have an example of like, here's how you would take a ingest a YAML file and produce a pipeline out of that. And it's like, relatively simple, and people have taken that and repurposed it. We actually had a user which took that. They went to connect this all together and built a full WYSIWYG drag and drop system on top of Dagster. So, it's a layered system that you can build on top of it. I think the other component that kind of is implied in what your question was kind of pre-built integrations and pre-built compute such that you don't have to write code in order to integrate with a tool in a straightforward way. And, our ecosystem of integrations is growing and continues to grow every day, both kind of in our mono repo as well as, out in the wild. We recently gave a talk at the Open Data Stack conference, and we were like, we don't have a Meltano integration. And then someone just Googled it, and lo and behold, someone had written one out in space. And that's the magic of open source in these ecosystems. So I think there's kind of two components there. One, just to summarize, we've written a layered system with well-structured APIs where you can overlay your own DSLs on top of this. And then, leveraging the power of open source and having clear pluggability points, the surface area of our integrations has expanded dramatically.
Another aspect of what you were saying there of not being prescriptive about how people are building their computations and how people are defining the sort of DSL that sits on top of Dagster to be able to be this more high-level data platform experience. I started using Dagster very early in the journey, and so there was definitely still a lot of experimentation of how you structure the repository, how you actually write out the different operations, and I'm wondering if there has been any sort of emerging best practice of how to actually architect the project, how to compose the different elements together and be able to units of computation that can be built on top of to build a sort of large and complex system without getting stuck in the trap of, dependency hell or, mountains of technical debt.
There's a lot to unpack there. Just in terms of good patterns and whatnot, I've been very pleased to see people dig into our resource system a lot. And without digging into too much detail, this is kind of the seam that allows Dagster computations to be far more testable than any other of its peer systems. People who kind of invest a little bit in their resources up front and set up like a development environment and a production environment see like massive productivity wins for actually like a relatively limited upfront investment, just to kind of think about it, get it right. And then, another thing that's been a really successful pattern for folks, which ties into your dependency issue, is instead of kind of making everything in one big pipeline and having three different teams, collaborate on that, having we call it like the mega DAG or the monolithic DAG. It's not particularly scalable. It's operationally really difficult. We've really pushed our users and encouraged our users to leverage our asset awareness to connect different teams' computations through event-based, what we call asset sensors. So, our system, you can set it up so that it tracks, like, okay, like a previous job says that I just updated this database table that's tracked in our asset catalog, and you can set up a downstream job to just listen on that and be like, hey, whenever this is updated, like kick off a new one. And that allows those two teams to operate in dramatically more decoupled fashion. They live in what we call separate repositories, meaning they can easily use different container images. They can deploy at their own independent rate. And they don't have to know anything about the structure of each other's pipelines. Like, I hate to break it to data engineers, but no one cares about the structure of your pipeline. No one cares. I know you're very proud of it. All they care about is the asset. So, by really doubling down on the asset is the interface between teams has been really successful. And that very much like lines up with the whole, not to get into the data mesh, because I don't want to start a Twitter fight, but I think one of the great ideas of the data mesh is that the asset is promoted as more important than the pipeline. And that's the API between teams. And that kind of structure reflects that. In terms of, anti-patterns and things which people shouldn't do, we built this very sophisticated configuration system, and we have this type ahead and all this stuff. And I think actually we encourage users to make things overly configurable and cause people to generalize things too early and do things in the config system that they should have just done in plain old code. And I think we're still kind of clawing that back a bit, actually. I think also sometimes the API is so lightweight, it's just a Python function. You're like, oh, I can decompose my pipeline into a billion little things. It's like, well, that actually can cause performance overhead and understandability problems. So, I think that, there's patterns like that we're still sussing out.
You mentioned the asset as kind of the boundary condition between pipelines and the API that is sort of foundational to how people are using and consuming data, and that's actually the sort of most concrete element of the work that we're doing. And I know that one of the concepts that you and the Elementl team and the Dagster product are starting to orient around and has become sort of an emerging concept within the framework is the idea of the software-defined data asset. And I'm wondering if you can talk through some of the ways that evolution of that as the kind of orienting concept has on the ways that engineers approach pipeline design and some of the ways that is influencing the direction of the API contract that you have within Dagster as to how you actually construct these different units of compute and then compose them into these larger DAGs and pipelines.
Yeah, well, first of all, thank you, Tobias, for paying such close attention to the product, since we have not aggressively marketed this experimental capability that we've never talked about in any sort of real public forum. There's, I think, a single GitHub discussion about it. But it's a direction that I am very excited about. And one interesting thing you said before about, X as code, that trend, I wish all of it was called software defined. So for example, infrastructure as code, generally people associate that with Terraform, right? Or some sort of declarative DSL where they made up their own language. I much prefer the term software defined because that is a little more expansive, where you could imagine a system like Terraform that was built on top of Python, where you could use functions and stuff. And then you end up using Python to construct in-memory software artifact, which is then kind of consumed by a system, and that structure is in reconciled and the same deployment concepts go. So we really put software-defined assets in that same lineage: software-defined networking, software-defined storage, software-defined infrastructure is a way to conceive of your data assets and manage them. We're still figuring it out. It's very early days, but I think you can provide a really elegant, intuitive programming model this way, where you no longer have to manually construct your DAGs, which is a huge, just short-term win. It becomes a very natural way to express the dependencies between teams. You kind of there's no way you can write the code without defining your asset lineage, which is awesome. I like to call this our property of the developers fall into the pit of success. By default, they're doing the so-called right thing. And then I think we can really shift the mental model of orchestration. Internally, we like to say like orchestration becomes reconciliation, where you think of it in a much more declarative way. And so, I'm very excited about the direction.
And I know that sort of in order to be able to support that more natural model of assets being the core element and the core conceptual aspect of the goals of the framework, I know that you have also changed some of the API models where originally the sort of unit of computation was called a solid, which has its own sort of interesting backstory to that. We don't necessarily need to get into it. And then there were sort of different levels of granularity for being able to compose those units of computation into the larger graph, where there was the pipeline, which was sort of its own special entity, but then there were also composite solids, which were a sort of subdag of a unit of computation, and you've been able to kind of break free from that and unify those into the idea of the graph. And I'm wondering if you can just talk through some of the ways that the idea of the software-defined data asset and these more streamlined API concepts have kind of played against each other as you explored that space more fully.
I mentioned the software-defined asset thing, which is a very experimental capability that we're just starting out. What you just mentioned, kind of our latest release, 013.0, which kind of renamed a bunch of stuff. It turns out the name Solid was incredibly stupid. Like, I apologize to my team and the entire community. That's my fault, and kind of, had to like eat my sin there. I think, but more important than the rename is that, and I think Tobias, as a user, you can speak to this, is that the system had a lot of power before this change, but you had to like sift through some duplicative abstractions, and there's some goofy naming and all that stuff. So, we kind of took a step back and we thought from first principles, okay, but the users who have kind of reached through that muck and found the value, what's the value they have? And then what's the most elegant, most pure way to capture that value and express it? And the net result of that, I think the team did extraordinary work here. And effectively, I think the system has gotten more powerful while boiling down the concepts. There used to be like kind of like 6 or 7 concepts you needed to learn. And we boiled that down to like 3 or 4. When you do that in one of these systems, the core concepts interrelate to each other. So every additional concept you add in a core system, often there's this combinatorial explosion of like, oh, how does this thing interact with this? So I think this latest release is a massive step forward. And even though we're changing a bunch of names and we're making people change code and all that stuff, the feedback is off the charts positive, which never happens. So I'm thrilled with the results. And in a way, right, we kind of, by boiling down the system to a more stable, coherent core, it has now given us the space to move forward and build more capabilities on top of that, and it will feel better and, allow the more like what we call the progressive disclosure of complexity. And I think, it's just a much more stable foundation to continue to build, the stack of capabilities that we have. So incredibly excited about what just happened there.
Going back to one of the things you were saying earlier about the richness of metadata that can and should be embedded into the different stages of computation and the interrelations between the different computations that are happening, that's definitely one of the more powerful elements of Dagster that I appreciate, is that it does have this very expressive metadata graph and a lot of opportunities for being able to expose and propagate metadata in those units of computation. And I'm wondering if you can just talk to some of the opportunities for being able to take advantage of that metadata, both within the bounds of Dagster and some of the ways that it can be leveraged outside of the Dagster context and exposed into some sort of more universal metadata catalogs and data discovery tooling, and just some of the contracts and interfaces that you're thinking about for that.
Totally. So I'm a huge believer in allowing the engineer or the developer to directly encode metadata, like in their code directly, whether it's annotating the code itself, having metadata in the kind of their structured metadata in their logs so they can communicate during the computation, like interesting facts about things. And then also attaching metadata to the results of the computation. And by having metadata in all those different forms, you can provide enormous amounts of context about anything in the system, right? You can look up an asset. You can see information about that. You can then click on it, go back to the run that produced that asset. You get a ton of context about everything that happened in that run. Then you can go to the job that was the basis of that run, and you can see how the code was annotated, who owns it, and all that stuff. And by being able to fluidly navigate through the system, any stakeholder can get tons of context about what's actually going on. And it is so much more powerful than control Fing through a log. It is like, if you fully buy into it, it is incredibly powerful. So I'm a huge believer in that. And especially the format where the code itself is annotated with descriptions. So one of the nice properties in Dagster is you can load up these computational graphs prior to computation without any infrastructure requirements. You can just view the graph and get all this descriptive information. It becomes this very useful system of record for your data platform. In terms of extending the context throughout the rest of the system, one, everything that's exposed in our UI is backed by a GraphQL. Well, spoiler alert, a GraphQL API. So, people can integrate that into any of their tools. And we encourage that, right? We want Dagster to be the interconnective tissue, not the one tool to rule them all. And then, where I'm really excited to kind of integrate with other data catalog and metadata systems is to really dig in to this structured event stream that we produce to allow an arbitrary consumer to ingest that and then build up their own interesting indexes and integrate to their system. We have a built-in, what I'll call an operational asset catalog that tracks assets that are produced by the Dagster system itself, and we can enable interesting operational use cases. We're not interested in the universe of data cataloging capabilities, like crawlers and really complex ontologies that are expressed in tools like a Munson and Data Hub. That's not our business. We want them to be able to ingest our stuff. And I think the right way to do that, will be structured event ingest. But, all of these tools that I mentioned are actually quite early days. We haven't seen a massive market demand for those integrations yet. I'm excited for the day where that occurs, but before you're integrating a data catalog tool with a orchestrator and all this other stuff, you need to adopt it in the first place and kind of build up to those capabilities. So I think I stole this from Tomas from Redpoint, but I think he's right. The next decade in software engineering is the decade of data. And it's still super early days. So, I'm speaking in terms of aspirations, but this is kind of our general approach.
And so another interesting element of this is the case where you maybe have multiple distinct deployments of Dagster, and each of those deployments has their own set of computational graphs that they're concerned with, their own set of assets that they're trying to create, but they are still within the bounds of a given organization. And I'm wondering what you see as the path towards being able to gain visibility across those maybe multiple deployments or distinct graphs to be able to see sort of the full lineage where maybe you have a data asset that is the output of one pipeline and then the other installation has a sensor that is keyed off of that asset to be able to trigger another downstream pipeline, and then being able to kind of stitch that all together in one sort of comprehensive view to understand as the end consumer of that second pipeline where the overall graph started.
Totally. And that's really where our cloud product comes into play. I don't know exactly what date this podcast is going to be published, but I believe, and I will request, that it'll be after the announcement of the early access to our cloud product. And we consider those kind of enterprise capabilities. You could think of it like Dagster federation almost, where you're federating all the different teams in a really well-structured way. And, I'm really excited to explore all those capabilities. We're still early days out of this, but, we're building in capabilities where you can have cross-Dagster deployment, asset sensors out of the box, be able to provision those deployments very quickly with one click, and then have enterprise governance around those deployments and RBAC and, various kind of enterprise features around having, really a really full-fledged enterprise data platform built on top of Dagster. So, operating and the application logic to do all that is actually very complicated. And, it makes sense for us to centrally manage that stuff. And we can get into kind of the open source commercialization boundary as we go on. But, those sort of enterprise organizational use cases are definitely a focus of our upcoming or recently launched Dagster Cloud product.
Struggling with broken pipelines, stale dashboards, missing data? If this resonates with you, you're not alone. Data engineers struggling with unreliable data need look no further than Monte Carlo, the world's first end-to-end, fully automated data observability platform. In the same way that application performance monitoring ensures reliable software and keeps application downtime at bay, Monte Carlo solves the costly problem of broken data pipelines. Monte Carlo monitors and alerts for data issues across your data warehouses, data lakes, ETL, and business intelligence, reducing time to detection and resolution from weeks or days to just minutes. Start trusting your data with Monte Carlo today. Go to dataengineeringpodcast.com/Monte Carlo to learn more. The first 10 people to request a personalized product tour will receive an exclusive Monte Carlo swag box. Digging more into the cloud aspect, I know that you've been working on Dagster for a long time and you delayed the sort of commercialization aspect of it for a while until you were very certain of where it fit within the ecosystem, that you were solving the right problems. And I'm wondering if you can talk through some of the journey from, I have this idea of a product that I want to build, here's the open source implementation of it, I'm going to use this to explore the problem domain, to now I see a clear path towards a commercial option to be able to actually monetize this without cannibalizing the community that I've built up along the way.
So that journey, I always start with the developer experience. It's kind of, maybe it's because I'm a developer and I'm selfish, and that's who I empathize with. But, that's what I think of. I think that developers want to be able to solve their productivity problems and code without interaction with a commercial product necessarily. And also the technologies that I kind of like, what I'll call like an intimate relationship with the user's code, meaning there's a framework and it calls into the user's code in the same process. There's very practical reasons why you want that to be open source. Like the code's in the same stack trace and you want people to be able to build integrations and have a community. So even just beyond like the general notion that like, I like open source communities and I think they're incredibly powerful. And I thought the GraphQL experience, which I was directly involved with, and the React experience, which I witnessed close up but wasn't as involved with, was inspiring and made lots of people's careers and really democratized technology, and I wanted that to happen. But I think you need to figure out something that people want first. And I wanted to do that in the open source domain. I think if I went back in time, I might have kicked off the commercialization earlier, not because we needed to make money. Luckily, we had very patient investors who kind of get open source and were very on board for the like, hey, let's invest in the core technology and there's no rush to commercialization, because you kind of might like, trying to come up with a metaphor that isn't macabre, but that wouldn't prematurely kind of hamstring the technology. But, in the modern world, what's interesting is that there's an increasing comfort with hosted services where it's not like the old days where there was an open source technology and you're like pulling teeth to get people to use your commercial service. Now it's the opposite, where lots of people view the open source project having a SaaS offering as an adoption requirement, which completely flips the script, which has been a fascinating development. So yeah, I think that's been going on. I think we knew we wanted to do the big API change and simplify the system, but we knew we could also start building the commercial offering in parallel. So we kind of kicked off building the commercial product early this year and did that in parallel. Now with kind of the API we want to stand behind, and the early alpha users are getting a lot of value out of the commercial service, and we've matured that infrastructure. It just makes sense to kind of couple them now and move forward. And we really think it can kind of kickstart adoption and even accelerate that further and just provide a ton of value for our community who wants this. People don't want to migrate a database. It's the worst thing in the world. Well, not the worst thing in the world. In the scale of software engineering, it's a very annoying thing to deal with. And it just makes sense for a company to centralize and manage those issues on users' behalf. The company can do it way more efficiently. And so there's a very natural, mutually beneficial transaction there for users large and small.
In terms of the value add that you're baking into the cloud platform, I'm wondering if you can just talk to some of the ways that it's architected to be able to add some of those additional capabilities and simplify the operations of the system while still being able to sort of leave control in the end user's hand and maintain some of the sensitive aspects of data because of the fact that it is liable to have PII or regulated information or, security constraints imposed upon it?
Yeah, so we've chosen architecture that I think is increasingly becoming an industry standard, more or less. There's a few ways. Some people call it a managed control plane and a user data plane. Some people call it hybrid SaaS. Like our CI system does is build kite. There's an agent that lives in our VPC. It phones home to ask like, oh, should I kick off a job? And then the compute actually happens in our VPC. We pay the bill to Amazon direct, so there's not a tax on the compute. And that works really well. Databricks is similar with their so-called E2 architecture. Snowflake even does this to some degree. They deploy compute into users' VPC. So we have a similar model where our goal is to host as many of the stateful, complicated services as possible. So the metadata database, the web server, long-running processes that deal with scheduling, and so on and so forth. But then still have the user have control of their code and their data such that it can operate on any infrastructure from your laptop all the way to a K8s cluster. And there's just an agent that phones home and kicks off compute when there's something to do. And then we stream up structured metadata through that same channel or similar channel. And that powers all of our kind of operational tooling, our web UI, our asset catalog. And we think this provides, a great balance for people where, what's nice about the user cloud that we call it is that it's stateless. Like all it does is you kick off compute, it runs it for a while, and it spins down. So it's very amenable to fully elastic compute, and it's like a cloud native infrastructure. It's great for cost. You can run on spot instances, all that good stuff. So minimal operational overhead. But that's just the start of it. I think that we're really interested in exploring the various modalities of this. And as users, we'll respond to user feedback too. Like we'd be excited to either have more managed solutions or partner with people who can provide out of the box managed solutions. But, we've talked to dozens of early users on our wait list, and they seem overall very happy with that trade-off of having to do a little ops on their side, but they get to own their compute and their data. And then we kind of manage all the complicated, like stateful services that they don't have to manage. And then we can also provide value-add proprietary services on top of that.
As you progress along this journey of commercializing and delineating the boundaries between the open source project and the capabilities there and what you're building into this managed service, I'm wondering, what are the design principles that you're using to make those decisions as new capabilities come up as a possibility to add to one or the other, and some of the ways that you are kind of managing the governance and long-term viability of the open source project?
Yeah, I love this question, Tobias. And I think it's a really important one to ask open source founders because, if someone doesn't have a principled framework around doing this, they will be completely thrashed all the time by, oh, we have to open source this because our competitor did this. Or like, oh no, there's a new PM who has a different take on this and they want to be grabby and decide to deny capabilities to your community to coerce them to use the commercial service. And that's no fun, right? That doesn't provide predictability. I think that open source communities are very worldly and understand that we need to build a sustainable business. They understand that. They just want to be able to predict our behavior and have there be a fair business model that works for everyone. So in that vein, I think that we have our own framework, kind of starting with the HashiCorp model as a base foundation. So they kind of chop up the world between, I think they call it technical complexity and organizational complexity, where technical complexity is broadly in the open source domain and organizational complexity is in the commercial domain. And I thought that was a great place to start, but I thought, given our context, we could kind of even go a little further than that. So instead of two complexities, I kind of subdivide the world into three. One is application complexity, meaning like how users structure their code, and very concretely how they consume and interact with the open source Dagster framework, right? There's kind of like some rules you can depend on. Like if the code is in process with your code, it's going to be open source. Right? If you're pip installing Python, that's going to be open source. The basic core framework level will always be open source. Then there's what I call the enterprise complexity, where you're dealing with like SOC 2 compliance and governance and all of these capabilities, which are very expensive to develop. and very complicated. You want to be able to change things quickly to fix bugs and develop new product capabilities and all that. The people who use those capabilities want a commercial contract. They don't trust a pure open source solution. So literally, you're enabling usage by providing, like a commercial contract is like a thing that business people understand. It's like, oh, I'm paying you money and you have this obligation. And that makes sense. So there's application complexity, which heavily biases, maybe even 100% biases towards open source. And then there's the enterprise complexity, I'll call it, which people want a commercial relationship. I think the interesting one that's fraught that people struggle with is this middle category I call operational complexity. So operationalizing these computations, because there's this balance of you want open source users to be able to use this in very real scenarios, because our goal is to make Dagster a durable open standard. And you don't want to coerce people to use a commercial product in order to use and push forward the standard. We don't want that. But there's this opposite thing where if you put 100% of your operational capabilities in the open source domain, one, you are subject to disruption by the cloud providers. That defensibility is real. Second of all, and I think this is underappreciated, maybe actually kind of the determinative here, is that it is much slower to develop things in the open source domain. So, if you open source an entire complicated infrastructure, which has multiple interacting backend services and whatnot, there's actually very few organizations on the planet who can actually run that thing effectively. And then like debugging all those issues at all those installations across all those open source users is a huge tax on the team, right? And we don't have the engineering throughput to deal with that. So there's like this very practical issue that some operational capabilities make a ton of sense to centralize because you want to be able to move fast. You want to have more engineering throughput. And then if the only organizations that can run it anyway are yourself, maybe the big mega tech companies and the cloud providers, that doesn't help anyone. So I really categorize it between like operational capabilities that have massive economies of scale to centralize. Like, for example, if we could never have one of our open source users run a database migration ever again, that would be awesome. It is so much easier for us to do that on the user's behalf. Just as like a super concrete example of this centralized economies of scale I'm talking about. But we are also going to have an open source Kubernetes implementation of the system. And we would never like deny a bug fix to the open source community because we want to like get them to use the non-buggy software. First of all, it's ridiculous. And second of all, it goes against our values. And there's no economy of scale benefit from fixing that bug. So that's just to summarize again, there's like application complexity, that's open source, enterprise complexity, that's proprietary and centralized. And then you can kind of like chop operational complexity into one, if it's complicated enough that not that many people can run it anyway, and it benefits from centralization, that's proprietary. And if it's, just like building a Kubernetes executor that has very strict and very well-defined properties, but that is pluggable so you can like extend it and whatnot, that is in the open source domain. We'll be writing information. It's a complicated, there's a lot there. So, but that's kind of the general framework of how we're approaching things. And we'll be writing more about this as time goes on.
Yeah, and that all makes good sense. And specifically in terms of the operational aspects of it, if you do have a sort of prescribed way of deploying everything end to end, and this is just how Dagster works, then like you said, it's never going to fit everybody's use case. And it's going to be a point of friction for adoption because if somebody says, oh, well, the only way I can run this is if I run this one script that happens to deploy 6 things into Amazon and 5 things into Google, well, I don't use Google and I don't want to put anything in Google. Why would I ever do this? And so having those kind of defined interfaces of, this is how it runs. These are the layers that you can add your own capabilities to run it in the way that you want it to. But if you don't want to deal with that extra engineering overhead on your end, then, pay us whatever it is per month and we'll deal with it for you.
Totally. And I think the other thing about this is that I think there's this implicit contract with the community as well that, where we want to get to is a fair usage-based pricing model where both the small players and the large players can participate in a way that feels win-win for everyone. And that's like, I'm not saying we're going to get there tomorrow. There's a lot of work to do there, but that is the eventual goal. And I think that, I don't think people give open source communities enough credit. Everyone's grown up. And they know that, and our goal, unapologetically, we want to build an awesome open technology and standard, and we want to build an awesome business on top of that. And we think that is beneficial for every stakeholder in the ecosystem.
So as you are iterating on the core product of Dagster and the commercialization efforts, and you have this sort of ambition of being an open standard for data computation, I'm wondering what you see as some of the potential threats to the future success of the Dagster product and the Elementl business.
I think the threats are still at a basic level, which is like, will enough people get enough value out of us? Like, I'm an optimistic founder, so of course I believe that, but we still need to grow the technology and make sure it applies to a broad enough set of people to make it a project worth investing in, a business worth building. So, there's always that existential threat, which is like, is the thing you're building what people want? And, we're definitely on the path there, but that needs to be proven out at greater scale. So, that's what I think about mostly. I guess, other existential threats are if some of the core premises of the business or the project are not true, right? If this whole notion that, the software engineeringification of data is not the massive wave that we think it is, and instead it's like a niche thing, and we can all move to a no-code solutions where there's no engineer in the critical path at all, and everything's going to be solved by managed services, and the engineers can go home and, retire or cry, depending on their position in life, I guess. I don't think that's true. I think the path forward is not to eliminate engineers, but to make them more productive. And I think there's this glorious flywheel as a result of that. So anyway, I'm trying to refute the existential threat in person. But if some of the core underlying assumptions of the project are not correct, then that's, potentially a threat to the business. But other than that, I'm not too concerned. I'm very confident about the future of the project and the company. I was struggling for these answers, actually, but I had to say something.
And then going back to the beginning of the conversation, as we mentioned, to some people's eyes, you're a relative outsider to the land of data engineering and data management. And, you've been here for 4 years, give or take now. And as somebody who is a relatively new entrant to the ecosystem, I'm wondering what have been some of the most interesting and surprising experiences and sort of lessons that you've learned about the overall space that you have encountered as you have been investing your time and energy and contributing to and growing this community that is sort of very deeply nested in sort of the core concern of the data ecosystem.
I mean, I don't think it's surprising, but I was gratified. I think that people in data are very excited, and data engineers have a reputation of being grumpy old people who like their tools, and they're like, get off my lawn. But I don't really think that's true. Through large swaths of the data community, there's a lot of open-mindedness. I think there's a lot of acknowledgement that there's a ton of work to do. There's a lot of different projects and teams experimenting in different directions. I think the vast majority of which, even people who are putative competitors, it's a very collaborative relationship in the vast majority of cases. So I think that has been good. I think one thing that I underestimated, and maybe this is because of my background at Facebook, where there are centralized infrastructure teams taking care of all sorts of other issues, is just how big of a deal simplifying the DevOps story for all of this stuff is. Because I originally set out to build a software abstraction, and I'm like, the infrastructure is someone else's problem, right? But we've had to vertically integrate more, and the deployment and DevOps aspects of this stuff and sanding off all the edges and improving docs and all this stuff is just so critical for onboarding adoption. And I think I would have realized that earlier. Definitely, I think we would have front-loaded the cloud product more and focused on that earlier. But, I'm also really excited about the capabilities. And I think kind of coming things up from fresh perspectives is good, but you need to partner with people in the ecosystem. But, I think some of the capabilities of our cloud product are really exciting. We're heavy Vercel users, which is kind of like a hipster JavaScript hosted environment that has these this amazing DevOps story. And we're really inspired by that. And our goal is to kind of create a Vercel level deployment and user experience, but in the data domain. And I think that's like a complete alien concept. I'm obviously hyping things up, but I'm very excited to see what the reception in the marketplace will be for that. So yeah, I think those are the two things. I think it's been cool. Like, I think it's a crowded ecosystem, but the vast majority of people are very open-minded and collaborative. I think, all this DevOps and infrastructure stuff, people are just struggling. There's no centralized infrastructure team coming to save them, and I don't think I'd really kind of, aligned my head to that given my background.
As you have been building out the Dagster team and the product and the sort of community around it, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
If there's one thing that, we bias towards pluggability and flexibility, and sometimes at the expense of kind of things not being out of the box enough. But the trade-off of that is that people come up with all sorts of stuff. One of my favorites, and he spoke at a community meeting. It was either a company contracted by IKEA or IKEA itself, where he repurposed Dagster to be in the critical path of the application to render 3D models of furniture. And they were able to repurpose, because they needed an orchestrated DAG compute and they liked the pluggability points and all that, but using it for a completely different use case than I anticipated. I think we only one of the orchestration systems that really works on Windows. That's been really cool because it's been a kind of an entry point to a lot of single players, so to speak, who worked in more lockdown IT environments where they have to run on Windows. And I'm really passionate about that because one of the things I was most gratified by the GraphQL experience was how it penetrated legacy enterprises earlier in its life cycle than I expected. It was like, okay, kids in Soma are using it. But then really early on, Walmart and KLM was using that, right? And because of this Windows capability, we have folks at Honda using Dagster, right? And I really like that dynamic. And then the other thing, I mentioned the person who built the drag and drop GUI interface. I thought that was fun. One story I really like is at Good Eggs. They run their entire data platform on Dagster. They actually trained their non-technical staff who work physically on the warehouse floor to use Dagster operational tooling, because they have to ingest data from their contractors, and then sometimes that data is malformed. They have to retry it and whatnot. And the platform team did a bunch of work up front, but they were able to make it so it's self-serve by people who are literally on the warehouse floor. And that was really gratifying to see that our investments in kind of our consumer-grade UI tooling paid off, where kind of a non-engineer, business, not even an analyst, just like a business user can come in and with just a little training can intuitively use the system. And that was great.
In your experience of being a founder in this space and building the product, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think that we probably moved a little too quickly at the beginning, because my mental model was the same development style that I'd used internally at Facebook to develop a lot of the core infrastructure there. And we moved super quickly and we made mistakes and we corrected them. In open source projects, it's way harder to change a mistake. Because at Facebook, I could just if I made a mistake and I needed to change the name of a method or something, I could just be a madman and like stay up all night and like change all the call sites and then move on with my life. That's not possible in the open source domain. And I don't think I really internalized that lesson from the GraphQL experience, because with GraphQL, it was like a well-formed, coherent thing. And we open sourced a spec, which has really stood the test of time because it was like well-baked by usage. So the artifact we open sourced was kind of this durable thing. Whereas with Dagster, we were trying to do a new thing and really push the boundaries on a few different dimensions and coming up with ways to achieve the outcomes we wanted to achieve. And, I think like this latest release I talked about is kind of paying the price for that. We had to correct some goofy names and consolidate some abstractions. So that's been kind of a humbling lesson. And I'm really privileged to work on a team that, one, was able to do that, but two, also willing to do it. Because it's like, oh, Nick, if you would have just like not done that, then you would have saved 3 months of my life, cleaning up your bullshit, to use a blunt term. But everyone's been super cool about that. And our community has also been great on that front. So I guess that's very top of mind because that just happened.
And so for people who are looking for some foundational component for their data platform, or they're looking for a way to manage these graphs of compute in their ecosystem, what are the cases where Dagster is the wrong choice?
I think it's the wrong choice. Let's see. We don't handle like real-time applications or streaming. The example I gave, slightly to the contrary of the person at IKEA, was kind of a real-timey case, but they really did some clever stuff to make that work. So I think that makes sense. We really target data platforms. I think other folks in the space are much more focused on pure orchestration applied to anything, right? So like CI/CD pipelines and, any sort of workflow orchestration. And like why you can use Dagster for that, that's not our focused use case, Like we are focused on the use case where you're building a data platform, and the purpose of that platform is to build, manage, and curate data assets. That's our business. It was funny. One of our design partners is a very sophisticated user system, Mapbox. The person I talked to there was like, we communicate this fairly clearly. And one of his stakeholder teams was like, I want to use this for CI/CDs. Is that allowed? I'm like, well, you can do whatever you want. Like it runs code in order and it retries things. So, you can use it for a CI/CD pipeline. I think it works reasonably well for that. But our tooling will not be focused on that use case. So, that's kind of my answer.
As you continue to iterate on the commercial product and the open source community, what are some of the things you have planned for the near to medium term, and any particular projects that you're excited about?
Yeah, the one I mentioned before, the software-defined assets, I think is really, really exciting. And I think that's going to open up like huge possibilities in our tooling. Like I think we can like completely reimagine the way that backfills work. I think we can really go a long way towards making a much more modern data stack, dbt native orchestrator. And I think there's a real market need for that. I'm also really excited to kind of program model married with our cloud environment. I think we can help a lot with the problem of creating ephemeral development environments for data practitioners where they can just push something up to a branch. And then the infrastructure team would have to work to do this, but effectively automate the process of like, okay, you're developing your data assets. Okay, make a copy of the input data, have test schemas, all that stuff, and have a really safe environment where you can iterate quickly in a cloud environment. I'm really excited about that. And then, in terms of cloud, I get excited when you can use a technical system to kind of help with the organizational API problems, this kind of deployment federation stuff we were talking about earlier. And, we're starting at this like pretty base layer for Dagster Cloud where it's like, okay, we're making it easy to spin up a deployment, we're managing your ops, but I think there is so much runway in managing all that enterprise and organizational complexity for tons of use cases that can bring in way more stakeholders than any other orchestrator out there. So, those are kind of the immediate directions I'm excited about.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
All right, this is like an unfair question to ask of someone who's building the infrastructure, because of course, like you only think about, what your stuff is. I guess I'll refer back to the capability that I was talking about before. This notion of having a fast development lifecycle when there's a bunch of managed services involved and you need to like make copies of production data and like all this stuff. And I think like the orchestration system will have a part to play there, but you can't solve that alone. And I think just the ability to do that, to be able to have multi-tool environments where you can just iterate on test data, you're not going to do anything bad. It would be a huge unlock. And like I said, I think that's an ecosystem-wide problem that will take a lot of collaboration, but I think that's a huge hole.
Well, thank you very much for taking the time today to join me again and talk about the work that you've been doing on Dagster. I'm definitely excited to start applying it more to my own environments and build up some more abstractions on top of it. So definitely appreciate all of the time that you and the team have put into it, and I hope you enjoy the rest of your day.
Thanks so much, Tobias. Thanks for having me.
Thank you for listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.